So in this video, we're going to see problems from exercise 8.4 and we're going to see problem number 4. Let's read the problem. Choose the correct option. Justify your choice. So we are given 4 problems here, first, second, third, fourth. And for each problem or each problem, first, second, third, fourth is nothing but an algebraic expression which involves trigonometric ratios. And each of them has 4 options A, B, C, D, and we have to choose the correct option and we have to justify our choice. Okay, so let's go with problem number 1. Let me try to zoom in. Yes, let's read it. So the first problem is 9 sec square a minus 9 tan square a is equal to what? Okay, so this is a problem which I think which you can immediately guess is based on the trigonometric identity. What is the trigonometric identity? We have 1 plus tan square a as equal to sec square a. Okay, this is a trigonometric identity. So therefore, I'm going to move this tan square a to the right hand side of the equation. Okay, therefore I'm going to get 1 as equal to sec square a minus tan square a. Okay, just shifting this tan square a to the right hand side of the equation. Okay, and now if you look at this given question, so 9 is common. Okay, 9 is common in both these terms. So this can be easily written as, so this can be written as 9 common. So sec square a minus tan square a. Okay, and now we have from this identity sec square a minus tan square a is equal to 1. So if I substitute this here, this is going to be 9 into 1. Okay, which is going to be equal to 9. So thus, if you solve this first algebraic expression, your value is going to be 9. So option B is the right answer. I'm going to tick mark it. Okay, now let's clear this. Okay, now let's see what is the question number 2. So let me bring it down. Okay, now question number 2 reads 1 plus tan theta plus sec theta, this is first bracket, multiplied by 1 plus cot theta minus cosec theta, this is second bracket. So these are two algebraic terms which are multiplied with each other and they are equal to either 0, 1, 2 or minus 1. We have to figure them out. Okay, so let's start with this first bracket. So I'm going to put this bracket here and I'm going to write, first let me write the question as it is, 1 plus tan theta plus sec theta, this is my first bracket, and the second bracket is 1 plus cot theta minus cosec theta. Okay, this is the second bracket. Now in order to evaluate these brackets, what I'm going to do is I'm going to convert each of these trigonometric ratio in its basic or the foundational trigonometric ratio, which is sin theta and cos theta. So let's rewrite each of them in terms of sine and cos. Okay, so that is equal to 1 will be as it is, tan theta is sin theta upon cos theta and sec theta is 1 upon cos theta. Okay, so this is my first bracket, and second bracket is 1 plus cot theta is cos theta minus, sorry, divided by sin theta minus cosec theta is 1 upon sin theta. Okay, so I've just rewritten all the terms in sine and cos, which are our foundational trigonometric ratios. Now let's try to solve this first bracket. Now that will be equal to 1 plus sin theta plus 1 the whole upon cos theta. Okay, because the denominator is same, this denominator is same, so we add the numerators. And similarly here we are going to have 1 plus cos theta minus 1 the whole divided by sin theta. Okay, same concept, the numerator is same, sorry, the denominator is same, so we do the operations at the numerator. Okay, now let's continue this. Now further, if we try to rearrange, okay, this is going to be cos theta plus sin theta plus 1 the whole divided by cos theta. Okay, and the second bracket is going to be, okay, and the second bracket is going to be sin theta plus cos theta minus 1 the whole divided by sin of theta. Okay, so now we have resolved the bracket number 1 and bracket number 2 and all are in terms of sin theta and cos theta. Now we can do the actual multiplication. So let's me use a different color. Now I will start doing the actual multiplication. Okay, so how does our multiplication work? So let's use a highlighter here. So cos theta is the first term and it will be used to multiply each of these terms. So cos theta will multiply all these three terms, then sin theta will multiply all these three terms, and then 1 will multiply all these three terms. Our regular multiplication when it's bracket. So first we start with cos theta, the one which I have highlighted. So cos theta into sin theta, that is cos theta into sin theta, okay, plus cos theta into cos theta is cos square theta, and minus cos theta into 1 is cos of theta. Okay. Now next we use this second term which is sin theta. So that is going to be sin theta into sin theta, that's going to be sin square theta, plus sin theta into cos theta is just sin theta into cos theta, and sin theta, sorry, minus, and sin theta into 1 is minus sin theta. Okay, and third one is just the term 1, so I'm going to multiply 1 to each of these terms. So 1 into sin theta is going to be sin theta, plus 1 into cos theta is going to be cos theta, and minus 1 into 1 is going to be just 1. Okay, so we have multiplied the numerators. Now the denominators just going to be cos theta into sin theta. So this whole thing is a numerator divided by cos theta into sin of theta. Okay, so this is a huge numerator which consists of almost 9 terms. Yes, which consists of 9 terms. So no need to get confused. This problem is a little bit lengthy, but it's not at all difficult or complicated. You convert each of the terms into sin and cos theta and you just multiply them. Now within these numerators we have 9 terms and a lot of terms get cancelled with each other. So let's try to focus on that. Okay, once again I'm going to use the highlighter. So first of all, if you note, this is minus cos theta. Okay, this is minus cos theta and this is plus cos theta. Okay, so again cos theta minus cos theta is going to be 0, so they cancel each other. Okay, then this is our sin theta and this is also minus sin theta. So sin theta minus sin theta, they will cancel each other. And then next we have this cos theta sin theta, cos theta sin theta. They will add to each other. They will be 2 cos theta sin theta. So I'm just going to write down that first. Okay. So this pink cos theta sin theta, cos theta sin theta, they will just add to each other. So that is going to be 2 times cos theta into sin theta. Okay. Plus then we are going to have, okay, sorry. Then we are going to have cos square theta plus sin square theta, which is actually equal to 1. But let's write down first cos square theta plus sin square theta. Okay. Then we have minus cos theta plus cos theta, so they get cancelled to each other. And then we have minus sin theta plus sin theta, they also get cancelled to each other. And the last term which is remaining is minus 1. Don't forget this. This is the minus 1. So I'm going to write here minus 1. And then we have our denominator, which is cos theta into sin theta. Okay. And now we again are going to use our trigonometric identity for cos square theta plus sin square theta. Let me use a highlighter. Yes, so this is our trigonometric identity cos square theta plus sin square theta, that is equal to 1. Okay, and so this is 1 and 1 minus 1 is also again going to be equal to 0. So I am just going to write it down here, 2 cos theta into sin theta, okay, plus 1 minus 1, and once again the whole divided by cos theta into sin theta. This is our denominator. Now 1 minus 1 is 0. So what remains is 2 times cos theta sin theta, the whole divided by cos theta sin theta. And again cos theta sin theta are just going to cancel each other out. So okay, let me use the highlighter. So this will cancel, this will cancel, and the final answer that will remain is 2. So 2 is the answer of this algebraic expression. Now let's come to the options. Yes, out of all these options we see 2 as option number C. So I'm going to mark C as our right answer. So in this problem you note down that the terms, initially we converted all the terms into sine and cos, and then we just kept on solving, did the multiplication, and then a lot of terms got cancelled with each other, and finally what we got is 2. So the problem was a bit lengthy, but you have to be patient, you have to be focused. Do not miss out any terms while opening up these brackets, and finally you get the answer as 2. So yes, 2 is marked out. So now let's erase this. Yes. Okay. And now let's come down to our problem number 3. Okay, so let me take this down. Okay, now let's read the problem number 3. It reads, again a bracket is given, sec a plus tan a, and this is another bracket 1 minus sin a. And if you do this multiplication, we have to say whether it's a, b, c or d. So quite similar to this previous problem where two brackets were given, and we are going to solve it in exact same way. We are going to convert each of these terms in sine and cos, okay, which are our basic foundational trigonometric ratio. Convert this into sine cos, convert this into sine cos, this is already in sine, and then open up the brackets, then do the multiplication, and then see what is the actual answer. So let's begin. I'm going to write the terms first. So this is sec a plus tan a, first bracket, and second bracket is 1 minus sine of a. Okay, now what is sec a? It is 1 upon cos a, plus what is tan a? It is sine a upon cos a. Okay, and this is already in sine, so no need to do anything. Okay, now once again, if you note, the denominators are same. If the denominators are same, we add the numerators. So let's continue. So that is going to be equal to 1 plus sine a, the whole divided by cos of a. This is my bracket number 1, and second bracket is 1 minus sine a as it is. Okay, so be careful of the brackets, don't mess up with the brackets. Now everything is in sine and cos. Now we go ahead and open up the brackets. Okay, so as you can note that this bracket is a plus b, and this bracket is a minus b. So let's make a note here. So we know that a plus b multiplied by a minus b is equal to a square minus b square. Okay, so we are going to use this same identity and solve this ahead. So basically this is going to be 1 plus sine a multiplied by 1 minus sine a, okay, and then this whole thing divided by cos of a, right? Now let's go ahead, let's use this identity. So this is going to be a square 1 square minus b square, which is going to be sine square. So this is going to be a square minus sine square a, and then this whole divided by cos of a. Now now again we have one more identity. What is that identity? Sine square a plus cos square a is equal to 1. Okay, and therefore I can say cos square a is actually equal to 1 minus sine square a. Just rearranging, just taking this sine square a to the right hand side of the equation. Okay, so 1 minus sine square a is actually equal to cos square a. So I'm going to substitute that in this equation. So let's continue. So this is going to be cos square a, the whole divided by cos of a, and this is nothing but cos of a, the whole square divided by cos of a. Okay, note cos square a and cos a the whole square are the same things. It's just different way of representation, but they both are exactly equal. So that is finally going to be equal to just cos of a. So our answer has come equal to cos of a. Let's see if any of the options has this. Yes. So option number D has cos of a. So I'm going to just tick mark that. Option D is the right answer. So this is how we have solved problem number 3. Now once again let's erase this. Okay, and now let's see the last question. Let's remove this, which is question number 4. Okay, so once again we are given a fraction of trigonometric identities, which is 1 plus tan square a, the whole divided by 1 plus cot square a. Again the same process, the same logic, the same steps that we are going to follow. Convert this into sine and cos, convert this into sine and cos, and then keep on solving it. So let me write the question first. This is going to be 1 plus tan square a, the whole divided by 1 plus cot square a. Okay, now let's convert them into our basic sine and cos. So this is going to be sine a upon cos a, the whole square, right? The whole divided by, this is going to be 1 plus cot a is cos a divided by sine a, and the whole square. Okay, now let's open up the brackets. So that is in fact equal to 1 plus Okay, sine square a the whole divided by cos square a. Just open up the square term, the whole divided by, this is going to be 1 plus cos square a the whole divided by sine square a. Okay, quite simple, straightforward, no complex operations there. Now this is going to be, now I'm going to take this cos square a to the numerator, so this is going to be equal to cos square a plus sine square a the whole divided by cos square a. This is our numerator, and now denominator is going to be sine square a plus cos square a the whole divided by sine square a. Okay, so now once again we have got a trigonometric identity, a very simple one. Sine square a plus cos square a, this is 1. Sine square a plus cos square a is equal to 1. So let's come down here. So this is going to be equal to 1 the whole divided by cos square a, right, divided by 1 divided by sine square a. Okay, and now we are going to, so now this sine square a, this sine square a should be taken to the numerator. How we do it is, okay, so we multiply, okay, so we multiply this, okay, let me use a different color. Basically we multiply the numerator and the denominator by sine square a. So multiply the numerator and denominator by sine square a. If you multiply numerator and denominator by the same value, the value of fraction does not change. Okay, if you multiply numerator and denominator by the same term, the value of the fraction does not change. Okay, now this sine square a and this sine square a will cancel each other. Okay, so this and this will cancel each other, and what we get finally is now equal to sine square a, okay, divided by cos square a. This is that sine square a, sine square a, sine square a divided by cos square a, right? And that is nothing but, in fact, it is equal to tan a tan square a, because sine a, so okay, just to clarify, let me erase this. Okay, so this is in fact equal to, this is in fact equal to sine a upon cos a the whole square. Okay, we can write it as sine a upon cos a the whole square, and sine a upon cos a is nothing but tan a, so this is going to be tan a the whole square, which is equal to tan square a. So our answer has come tan square a. Now let's come back to the question. Yes, we have this option number D, which is tan square a, so I'm going to tick mark D. So thus, for all these 4 questions that were given to us, 4 problems, we have solved them. Okay, we have opened up the brackets, solved them. The basic concept or the basic idea in all these questions were, you convert each of the trigonometric ratio in sine and cos, and then open up the brackets, then do the multiplications, and then see what comes the final algebraic expression or the final trigonometric identity. That's all.